There we are. We're live. Excellent. Excellent. For those of you in the chat, I'll remind you a couple times over. But if you could, it's open. If you could, you can leave a comment in the chat. That would be absolutely wonderful if you would. And we'll kind of get this thing moving for today. Last time we talked about the beginnings of exponential word problems. And you guys had the practice with setting up exponential word problems and whatnot. Just some, interesting stuff from my perspective, just because it's like, this is one of my favorite chapters in all of Algebra 2. But we have to go back to the algebra a little bit today. I have to teach you a couple of key skills before we jump back to word problems. Because when you're facing these exponential word problems, eventually the question will come up about solving for a certain variable. And unfortunately, you do not have the skills in any of your mathematical training to solve something like that, which I'm going to get into the details of. So if you would, ladies and gentlemen, if you do not already have them out, I'm going to need those notebooks out and open. For those of you in the chat, again, I would love it if you would leave me a comment there. That'd be wonderful and fantastic. Even though it looks like there's only 5 right there, it's almost like people just jump into the chat and leave a comment and then leave. And they're like, oh, I wonder why my grade's so bad. Oh, maybe because you don't stay for the lesson. All right. Flip this over. Chapow. Unfreeze, refreeze. There we go. Oh, it's open. I got you. I don't know. I did that like 10 minutes ago. I forgot to take it back out.
No worries.
It's all good. All right, let's see what we got here. Today is the 25th. And this is like an intro to solving exponentials. Zoom in. Intro to solving exponentials. So let's start with just something very basic, very straightforward. Something like this. This is probably one of the more straightforward exponentials that you may end up seeing over the course of this chapter in terms of solving something like this. Solving something like this just means to get x by itself, to figure out the value of x, to isolate x. And it should be, theoretically, it should be very straightforward to look at a problem like this and just kind of like, okay, 3 to some power gives me 27. 3 to some power gives me 27. What is that power? 3 to what power will give me 27? Well, you can say it. There you go. He gives me the hand gesture. No, but 3 cubed, 3 to the 3rd power. It's very straightforward to look at something like that and be like, oh, yes, of course. Now, I'm going to write down a little bit more than just x equals 3. I'm going to write down just a little bit more. But I'm going to change that 27. 3 to the x equals, yes, it equals 27. It equals 3 cubed. Now, there is a property in mathematics that actually deals exclusively with what you see in front of you. And I'm going to write down that property in a few minutes. But when you have, okay, 27 is 3 cubed. What's the big deal? Well, if the bases are the same, then the exponents are equal to one another. If the bases are the same, then the exponents are equal to one another. This is a fundamental skill that we need to practice and hone over the course of this chapter. There are 2 major fundamental skills I'm going to be teaching you today, this being one of them. Here's the property. If a to the x equals a to the y, then, and I'm going to pause it there just for a moment with the then. Just the idea that, okay, well, if the bases are the same, if I have the same base on both sides of the equation, then I am allowed to say that the exponents are indeed equal to one another. This is a fundamental skill that we need to hone, that we need to put into good practice. Sometimes it'll be very obvious, sometimes it won't. It really depends on the situation. Let me give you a slightly different example that utilizes this skill. Let's say, for example, that I had 2 to the x power equals 8 to the x plus 1 power. Let me zoom in a little bit on that. Now, the property that we just wrote down does not apply at the moment. Let me repeat that. The property that we just wrote down does not apply at the moment. Why does it not apply right now at the moment? Why can't we not just jump right into it and set the exponents equal to one another? Oh.
This is a different?
Yeah. I can't do it. Crap. This sucks. What do you know about the number 8? Ooh. What do you know about the number 8? Is there a relationship between 2 and 8? Relationship between 2 and 8, something to do with exponents? Quickly, break down the number 8. What is number 8 broken down all the way? If you could break it down into its prime factors. Like 8 equals what? Like we broke this down into like a factor tree. That's what we need. That's what we need. That's what we need. Holy crap, hold on. There's a relationship here, which then we can utilize this property that we just wrote down before, where if the bases are equal to one another, then we can say that the exponents are equal to one another. With this problem right here, we can rewrite it. Into the following. Now we're getting there. We're almost there. Now we're looking at this problem like, can we set the exponents equal to one another now? No, unfortunately, we can't just yet. We're almost there. We're like a hop, less than a hop away. Ultimately, we have to get rid of these parentheses first. And the way we get rid of these parentheses, power to a power, if I have power to a power, what am I to do with those exponents? Power to a power, what could I do with those exponents? Take a guess at it. Take a shot at it. Oh, I'm covering it up with my knuckles. What would you like to do with it? That you think, I don't know if I'm right or not. Oh, no. We have to do this one thing, ladies and gentlemen. We have to do this one solitary thing before we can utilize that property. And you'll see this with a lot of practice problems that we have today. But we're going to have to do the following. What the heck did I just do? What did I just do to those two exponents? I did something to them. I kind of combined them, but using what operation? Using what operation? Oh, sorry, I was just looking at the comments. Oh no, the cat has caught your tongue. I think that's the phrase, right? Okay. You know, it's a weird phrase. More than one way to skin a cat. That's a weird phrase. You ever skinned a cat before? It's time consuming. You have to multiply these exponents together. You have to multiply these exponents together. When you have power to a power, you have to multiply these exponents together. This is a property that we were able to utilize at, I think it was like the beginning of the previous chapter. The beginning of the previous chapter, you need to multiply those two exponents together. As a result, technically, when you multiply them, there's a bit of distribution that takes place. So you do 3 times the parentheses x plus 1, which becomes 3x plus 3. Now, as a result, we can take those two exponents and set them equal to one another. Because the bases are the same. Now, we're almost there. We are almost there. We are almost at that last little step to get x by itself. We have x equals 3x plus 3. Let me write it a little bit higher so that you don't have to keep ducking down underneath your little barriers. Now it's just like a pre-algebra problem. I mean, honestly, I don't even know if you learned this in pre-algebra. But it's just a matter of getting this x by itself. Isolating this x, peeling off the outside layers until you are able to get that final value of x equals 1.5. Now, I'm going to prove it to you in a moment. I'm going to show you in the calculator actually why, or not why, but how this actually works properly. But that is the actual numerical value answer to this particular problem. This is an unbelievable skill to have. When we were setting up these exponential word problems the other day, I couldn't ask you all the questions that I possibly wanted to ask you because we didn't have this particular skill. We need this skill along with one other. Hold on, announcement.
Interruption of the following students. Please report to the main office. Noah McMahon, Corey Michaels, Miracle Modica, Michael Pizza, and Samantha Sapersky.
Sometimes they have an extra name at the end. Anyway, we need this skill combined with something else that I'm going to be showing you in a little bit to be able to solve those exponential word problems in every which way imaginable. Let me show you something on the calculator here. Boom. Let's see. Come on, calculator. Load up. Come on, calculator. Do your job. There we go. So, on this calculator, I'm going to prove that this answer was what it says it was. 2 to the power of negative 1.5, because it was 2 to the x power, gives us this crazy decimal. Now, I don't care what this decimal is. I don't care. I don't have to write that decimal down. Right now, I am checking my answer. And again, it's 2 to the x power in the original problem. So I just put in 2 to the negative 1.5 power. But in checking my answer, I'm just making sure that by plugging in negative 1.5, the answer is what it says it is. On the other side, it was supposed to be x 8 to the x plus 1 power. 8 to the negative 1.5 plus 1 power. If I'm correct, I should get that exact same silly decimal. But again, doesn't matter what that decimal is as long as those two decimals match. And if those two decimals match, then you have the correct answer. That is what we're looking for. Okay. For those of you in the live chat, I'm about to give you a worksheet, or I'm about to post a worksheet, I should say. For those of you in the live class, I'm going to give you this worksheet in a moment. So if those in the chat would hold on for just a second, I can get these passed out. Yeah, I got 4 in there. Back to there. I got 2 in there. You can have one too.
Oh, thank you.
Let's see here. Let's see. Open. Come on. PDFs for today. Post. There we go. So for those of you in the live stream, I just posted 2 PDFs that I want you to open. The one that I really want you guys to focus on first and foremost, make sure you're on the one that says 7-2. 7-2. The 7-2 practice is what we're going to be focusing on. With the time that we have left, I may have an opportunity to get to the second major skill for today, but it really depends on what we do with some of these problems. Now, some of these problems on this worksheet can be a little bit intense. They can be. I want to do one of the intense ones with you, and then we'll kind of see where it leads us. We'll see where it leads us. So let me flip my camera back. Let's zoom it in right here. I'm going to zoom in on number 2. I'll focus that camera. There we go. I'll zoom in a little more. But obviously, if you have trouble seeing it in the chat, you do have the PDF. If you have trouble seeing it in class, you do have the worksheet. So everyone's on the same page here. And I have this. Now, before, I showed you a problem that had 2 on one side and 8 on the other. And eventually, we were able to discover the fact that 8 is nothing more than 2 cubed. Ooh, we got a little bit of an issue here. We got a few things going on here. There's some decimals, there's some fractions, there's some larger numbers. I don't know, Mr. Murray, this is one I would probably skip. No, absolutely not. I'm going to walk you through this one. I'm going to walk you through this one. And then I'm going to give you an opportunity to try your hand at a few of them on this page. Now, first, strategy number 1, look at the base. Look at the base, look at the base, look at the base. On the left side, the base is the fraction 1 over 64. Ignore the 1 over for a moment and just focus on the 64. On the other side, the base is 8. Now, hopefully, just looking at the bases, you can recognize a relationship between 64 and 8. Now, there's 1, 2, 3. No, there's 2 main ones. There's 2 main relationships that you can determine between 64 and 8. What is the obvious one? 8 times 8, 8 squared. Yeah, that's the obvious one. There's one that's not so obvious. Do you guys know the one that's not so obvious? Sometimes I do get somebody who figures it out. The 8 squared one is the one I want you to figure out, though. That one you can figure out. That one, 8 squared, 64. Yes, there's the relationship. The one that's not so obvious is this. 64 is actually 2 to the 6th power. and 8 is 2 to the third power. We know 8 was 2 to the third power. There is a way to change them to be a base of 2, but if you can recognize that other relationship, you're in much better hands. The other thing that we now need to deal with is that 1 over 64. Now I'm going to show you exactly what that thing should look like. My red pen. There's my red pen. So I want you to write this down. And then I want to talk about how we're going to apply this. Oh, I got to zoom out just a tiny bit. There we go. I thought I wrote it small enough. Now, first, the right side didn't change. I didn't change the right side. It is what it is. No harm, no foul there. On the left side, I did change it a little bit more. And what I changed it to was actually an 8 to the negative 2 power. Now, you said 8 squared. Yes, I got that 8 squared there, but I have to have that negative in there. This, again, is a property that we've seen in... Oh, okay. Sorry, I thought there was like one of those like weird alarms going off outside. But we haven't seen this property since the beginning of chapter 6. And when I say the beginning of chapter 6, literally this specific property we haven't utilized in maybe a month or so. We used it for midterms, but this property, this relationship is very important. Now, it's so important that I am actually going to go back to the notes in a moment. I'll let you know when. I'm going to go back to my notes in a moment to rewrite the property because we need to know it for this particular problem. But again, what I want you to take away from this is this. Number one, the right side, I did not change. The left side, the only thing I changed was the 1 over 64. I made it an 8 to the negative 2 power. So let's go back to our notes temporarily. Let us go back to our notes temporarily so I can write down this particular property because we're going to be utilizing it a few times today. Zooming out, zooming out, zooming out. Here we go. The property is this. This is that property. A negative exponent, as we've talked about in the past, means that you have to recognize the word reciprocal. A reciprocal is going to take place. Whenever you have a negative exponent, you could take the reciprocal of the base and the exponent would turn positive. Or vice versa, if you have a fraction with that m exponent, you can take a reciprocal of that and turn it into a negative exponent. Now, the example that I have is exactly the problem that we were working on. 8 to the negative 2 power is nothing more than 1 over 8 to the positive 2 power. There, right where I'm walking up to, there, is your 64. We have to turn it into a negative exponent. We have to. In order to eventually solve the problem we were working on, we have to turn it into a negative exponent to get the bases to be the same. We need the bases to be the same. It's a weird way of using this property, but this is what we need. On this problem, zooming back in, make it focus. Come on, camera. There it goes. I needed to change that 1 over 64 to an 8 to the negative 2 power in order to get the bases to be the same. Once you get those bases to be the same, then we are on our way to solving this particular problem. I am going to have to multiply those exponents together, which I'm going to move the problem over in a moment. Here we go. I'm going to have to multiply those exponents together. Negative 2 times 0.5 gave you negative 1, or negative 1x in this case. Negative 2 times negative 3 gave you plus 6. Again, the right side stays the same. But once you get to this point, now we can utilize that property. Negative x plus 6 equals 9x minus 2. And we can solve this problem like we were back in Algebra 1. I'm going to add the 2. I'm going to add the x. I'm going to have to divide by 10. And I get an answer of 0.4. Zoom out. Zoom out. There we go. This is the skill we need for these problems. So, I want to give you the next little block of time to work on 2 specific problems. And again, for those of you in the live chat, just so that you are aware, we are on the 7.2 side of this worksheet. This worksheet is in your Google Classroom stream. I just posted it like 10 minutes ago. But I want you to work on a few specific problems, 2 specific problems. I would like you to work on numbers 1 and 4. 1 and 4. Put that up here. Number 1, number 4. We need to be able to recognize properties between these bases to be able to get them equal to one another. Number 1 might be a little bit more straightforward than number 4. Number 4 might test your skills a little bit more. Let's see what we got. I'll give you a little block of time, maybe the next 5 minutes or less. Go.
Don't worry. Yeah, we'll figure it out. You were more important.
just bought more shares. Like it's 6 a.m. previous time. I mean, like everyone did well yesterday. I don't know if you saw a lot of like 400 points. Some jump like that. But yeah, that thing is anything edge elastic related is technically open until I actually physically close it. Anything that's like quizzes, that website, dictate, or whatever the date I set it for, I can't reopen it after it closes. Because otherwise I have to purchase some membership quizzes. It's like, are you kidding me? I'll pay $60. Did I ever tell you guys the story of my supervisor who was from England? No. So that was my supervisor. It was just in the room. She's my new supervisor from like last year or whatever. I used to have a supervisor. Her name was Joanne. She was from England. She had a very thick English accent. And I was teaching, and she was observing in the back of the class. And I misspoke a word. Like I totally butchered a word. And I said something to the effect of like, oh, I don't need to speak English. I'm a math teacher. I'm never going to England. And I said that, and the whole class knew she was in the back of the class. And they're all just like, all of a sudden, they got like super quiet, and they're like, I can't believe he just said that. Like, they couldn't believe I said that in front of my British supervisor. I'm never going to England. And I thought it was hilarious. So, like, I went for like a high five for a kid in the front row, and the kid's like, nope, I'm not joining in on this. They thought I was going to get fired. Clearly, I'm still here. No, she loved it. She thought it was hilarious. But yeah, she was so British. I don't really have a follow-up to the so British joke, but that's about it. Anyway, let's see where this takes us. I had you do numbers 1 and 4. And I want to write this stuff down on a separate sheet of paper. After I go over these two problems, I want to show you how this could potentially relate to what we've been doing with these word problems, and how there is a second skill that we are going to need to utilize to get this stuff done. So, number one gave you the problem 4 to the x plus 35 equals 64 to the x minus 3. Now, there are two ways to go about this. There are two main ways to go about this. Number one, you could recognize the fact that 4 is nothing more than a 2 squared, and 64 is a 2 to the 6th power. You could change them both to a base of 2. And if you did that, that would get you towards the answer. You need to get both sides to have the same base. But a faster way of doing it would be recognizing that 64 is nothing more than 4 cubed. It's 4 cubed. 4 times 4 times 4. That's a shortcut way to do it. It's not the only way to do it, but in my opinion, it is the most straightforward way of doing it. Come on, little thing. There we go. Getting this piece of information means that we are also allowed to do this. Which is multiply the two exponents together. By multiplying the two exponents together, you'd have to distribute that 3. So it would become 3x minus 9 in this instance. Now we can set the exponents equal to one another, and we are back in Algebra 1. Being back with an Algebra 1 type problem is nice, but you have to work to get to that point. I'm going to subtract the x. I'm going to add the 9. I'm going to have to divide by 2. And I get an answer of 22. Let me zoom out a little. Show a little bit more of this problem in its entirety. There we go. Oh, that's cool. What is this? Sorry, I'm getting like random emails and messages. That's crazy. Anyway, let's look at number 4. Number 4 was a bit more intense. And after number 4, then I can show you some of the rationale for why we're doing what we're doing. So let's see. Number 4. Number 4 had similar numbers, 1/4 to the 2x plus 2 power equals 64 to the x minus 1 power. Zooming in, zooming in, zooming in more, zooming in more. There we go. Same process. Oh, look at that. The base on the left side is a 1/4. The base on the right side is a 64. Hey, I know that 4 cubed is what I probably need. Yes, 4 cubed. Good for you. Happy day. High fives all around. But the left side I'm going to have to change as well. This is what you should have done for the left side. That is what should have been done for the left side of the problem. You need to change that 1/4 to have a base of 4. And that is the negative exponent property that we wrote down earlier. We need that negative exponent property because you need to have both sides having the same base. In terms of multiplying the exponents together, I got to do that to both sides. I multiply the exponents together on the left. I multiply the exponents together on the right. And now, after all of that, I can finally set the exponents equal to one another because I have the same base. Being back in Algebra 1, I can finally take a problem like this. I can, let's see. I'm going to add 2x, and I'm going to add 3. Yeah, I'm going to add the 2x over to the right. I'm going to add the 3 over to the left, and I'm going to have to divide by 5. What a crazy problem. Again, more emails. They're telling me about study hall, and I have study hall in like 15 minutes or so. Okay. The reason why we need this, the reason why we're going to be playing into rules like this is to help us to solve exponentials. Let me give you an example word problem. Very basic one, very, very basic example word problem that kind of plays into what we're doing. So let's say 2 to the x power equals 128, something very basic. A bacteria cell, I know I've done this before, doubles every hour after how many hours will there be 128 cells? This is a very basic, very straightforward, very simple word problem that applies to what we've been doing. A bacteria cell, you start with one cell, that's the value of A, doubles every hour, doubles, that means that B is equal to 2. How many cells will there be? I'm sorry, how many cells will there be? How many hours will there be? 128 cells. After how many hours, I should say? Well, if we solved that problem, we could recognize that 128 is equal to 2 to the 7th power, and thus x equals 7 hours. And that would be a very basic, straightforward word problem that won't ruin your day. And now I stand up for dramatic effect. Repeat phrase about not ruining your day. And this is a very basic word problem that won't ruin your day. Dramatic turn. I'm reading the stage directions, just so you know. I'm about to show you something that may end up ruining your day. About to show you something very seemingly very basic, very straightforward, but it's something that I'm pretty confident you do not have the proper skills to solve just yet. Let me show you what I mean. I need precision when it comes to a word problem like this. I need absolute precision. And 2 to the 7th power is 128. That works perfectly. That's perfect. It's exact. There's no doubts about it. Here is something that may end up ruining your day. Give me a 2-digit number that's greater than 50. I can't do 64. Let's do 68. I can't do 64 because that one would actually work out perfectly. 68 does not. Look at this. Look at this. 2 to some power equals 68. 2 to some power equals 68. We have to solve. We have to get x by itself. I said I couldn't do 64 because if you did 64, then your answer is 6 right on the dot. If it's 64. But it's not 64. It's 68. I can't change this 68 to have a base of 2. I can't do it. There's no way of doing it. I can't change that 68 to have a base of 2. I have to get that x by itself. How do I do it? Again, this is something that you may, and I say may because I have absolutely no idea what you've been taught in Algebra 1, but this is something that I'm pretty confident you have no clue how to do because it's not been taught to you yet. How do you get x by itself? You have been taught some of the more basic operations in mathematics. You have been taught addition and subtraction. You have been taught multiplication and division. You have been taught squaring and square rooting. You've been taught raising to powers. You've been taught taking roots. None of that works here. None of it. None of it. You can't divide by 2 here. It doesn't work. It doesn't get x by itself. It doesn't get that 2 off the problem. You can't. I've heard some people, they've told me, hey, Ms. Markey, take a root of the problem. Take a radical. Okay, but what you can't take a square root. take an x root. Okay, no, I can't take an x root. That won't work. What do we do? What do we do? This is something that hopefully for the rest of your lives, you'll remember this moment. You'll remember this moment when I told you what you needed in order to solve this problem. What you need is a musical tree. I'm going to, again, dramatic pause. Repeat statement. What you need is a musical tree. What the heck is a musical tree? A musical tree in the realm of mathematics, you ready for this? Is a logarithm. Logarithm. Musical tree. Nobody gets me. A logarithm has been staring you in the face for years. Oh, it has been. A logarithm has been staring you in the face for years. Now, you may not have these calculators, but I can still show you. Zooming in, zooming in, zooming in, zooming in, zooming in, zooming in, zooming in. Focus. There it is right there. You have a button dedicated to the logarithm right on top of your calculator. Check this out. This is a scientific calculator. Oh, you can't see it. Zoom out. This is a scientific calculator. It's not a graphing calculator. It's not a graphing calculator, but look right there. Look right there. Zoom in, zoom in, zoom in, zoom in, zoom in right there. Do you see it? Log. Hold on. Hold on. I got to get to my, hold on. No, not that one. Not that one. That one. Check this out. This is my phone calculator. Yeah, Ms. Markey, I don't see log on your phone calculator. Oh, turn it to the side. And what do you see right there? There's log. It's been there the whole time without you knowing what it is or how to use it. I'm going to show you how to use it. It's going to be amazing. It's been everywhere this whole time. Every calculator, every phone you've ever owned, log has been on there. You just don't know how to utilize it. Here's the relationship. I'm going to put a little note over here. This is in my notes, ladies and gentlemen. Logarithms allow you to get an exponent by itself. Logarithms allow you to get an exponent by itself. If you ever have to solve for an exponent, this is the process that you could potentially go through. Now, there's multiple ways of handling this. I'm going to show you one very basic way today. Check this junk out. Oh, goodness gracious. Oh, come here, you. There we go. Look at that junk right there. Log base b of y, parentheses y, equals x.
That says B, right?
Yes, that's a little subscript. It's a little subscript of b. Is the same as y equals b to the x power. They are exactly the same. They are precisely the same. Now I'm going to show you multiple ways of handling this thing. But what we're going to do, very, very, very straightforward thing, is this. We are going to apply this relationship to the problem that I just put up there with that 68. And I'm going to wrap up with that. Solve 2 to the x power equals 68. Well, according to that relationship, it's the same as log base 2 of 68 equals x. Mr. Markey, what the heck actually is a logarithm? A logarithm is the inverse operation of an exponential. What we have up top here, when I said solve that, that is an exponential. A logarithm is nothing more than the inverse operation. It allows you to get that x by itself. It allows you to solve for the exponent. You're like, okay, well, what the heck is log base 2 of 68? This is where your calculators will come into play. Now, again, I'm not expecting you to open up the calculators right now, but I will show you exactly where it is in the calculator. Now, you do have a log button on your calculator, but this log button, if you can see this calculator right here, is actually not the log that I need at the moment. I'm going to show you over the course of the next several class periods, I'm going to be showing you multiple ways of handling this. This is just one way of handling it. If you hit math, under that first option there, frac, decimal, cube root, x root, I don't care about any of that. There's a function called log base. Now here's the thing. These TI-83 calculators don't have it. Your calculators on your Chromebooks have it. It does. It has it. Some of the more TI-84 advanced calculators have it. The 83s do not. But if you hit log base, it allows you to type in the numbers where you need them to be. Log base 2 of 68. It gives you that exact value. X is approximately equals 6.087. What that means is this. The calculator will be able to get this thing done for you as long as you know how to put it into the calculator properly. The calculator will get the calculation done for you, but you have to do the algebra to begin with. 2 to this power is 68. I know you said 64. Check this out. I'll just kind of leave you with this. Let's say I change that 68 to a 64. If I change that 68 to a 64, remember how I said it would work out perfectly? Kapow! Perfectly. Because 2 to the 6th power is 64. That's why I didn't want to do 64. Ladies and gentlemen, we'll pick up with this next time. I will see you on Monday. If you have not left a comment in the chat, please make sure that you do. I'm going to be signing off because I got to get to study hall. I'll give them a moment to comment if they haven't already. Don't get nervous when a supervisor comes in. That's good. I don't. Like, why should I? Well, you guys have no reason to be nervous because you're just students. That's my job. Well, whichever.